Imagine you have an equation x squared plus y squared equals to 1. As some of you may recognize this equation, it's actually the equation of a unit circle, where let's say we have a xy plane, sides 1, -1, 1, and -1. Alright, this is the equation of the unit circle, where it touches all points at 1, right? Now, imagine you have the equation, and maybe you want to find the slope at the point, maybe at 0.5, and probably 0.5 maybe, right? You want to find the slope at this point. Let me try drawing it. Yes, let's say you want to find the slope at this point. How do you find the slope? Or the tangent, I should say properly. Well, and that's where implicit differentiation comes in. To find the tangent of a circle at a given point. Now, how do we differentiate this function? Well, it's quite simple. Let's say we have the function x squared plus y squared equal to 1. We want to differentiate in terms of x, right? In terms of x, so d dx x squared plus d dx y squared equals d dx equals of 1. In this case, we derive x squared, we will get 2x. And then, when we want to derive in terms of x for y squared, how do we do it? Well, here's how we do it. First, you derive as you would normally do, 2y, but here, you have to add another dy dx. Or you can call it y prime. I prefer to use the word y prime. Right? And then, derive 1, you get 0. Now, you want to isolate the y prime to find the derivative, right? So, we bring 2x to the other side, and then we get y prime equal negative 2x divide 2y equal negative x over y. Once you cancel it out. Okay, now this is the derivative of a function. What does this mean? Right? Let's say we want to evaluate the tangent at the point, let's say x is 0.5, right? And y is 0.5, right? So we just input negative 0.5 over 0.5, and what do we get? We get negative 0.5 divided 0.5, just input into a calculator and you get negative 1. So the slope at this point is exactly negative 1. And that is how we use implicit differentiation. Now, let us try more challenging implicit differentiation question. Right, for the first question, d dx 2x3 equal d dx 2y squared plus 5, d dx 5. I prefer to write it this way. You can choose not to do so if you are more advanced, but it makes sure that you are not making any mistake, right? So 6x squared equal 4y, remember, y prime plus 0. Get y prime, you just bring it over to the other side over 4y, and we can simplify it. We will get 6 divided by 2, we get 3 x squared. 4 divided by 2 is 2y. And that is your final answer. For the next one, divide this d dx equal 5y squared equal d dx 2x cubed minus d dx 5 of y. Okay, simple as always. Differentiate as usual. and then add the y prime equals differentiate, and this is an x, so 6x squared minus 5y prime. Now, how do we isolate? We bring it over to the other side. Plus 5y prime equals 6x squared, and then we factor out the y prime because they are common factor. Plus 5 equals 6x squared, and then what we get is we bring it over and divide, so y prime equal to 6x squared over 10y plus 5, and that is your answer. Now, something a bit more challenging, right? For question 3, I challenge you to do it yourself first and then check it back, right? But dx 2x squared y squared. Now, in this situation, assuming that you have given it a go, 0 equals 3 plus, see here, over here, we have both x and y, right? And therefore, we have to use the product rule. Remember the product rule? So we just take out these two first because it's the constant. It's the product rule. I mean, it's the constant product, so we have to take it out, and then we have to find and we try to derive the inner function, the part first. So we get remain x squared, differentiate y squared, 2y y prime plus differentiate x squared, you get 2x, remain y squared. And that is the product rule. So slowly we try to expand it. 3 plus 2x squared, 4x squared y prime plus 2xy squared. Bring all the non-y prime to the other side, so you get 4x squared y prime equals negative 3 minus 2xy squared. And then you can always bring it over, so therefore what you get is y prime equals to negative 3 minus 2xy squared over 4x squared y, and that is your answer. Now, for the last question, alright, and as always usual, differentiate accordingly. Use the product rule here, and we get x y squared, maintain x, differentiate y, 2y y prime plus derive x equals to 5 3y squared plus 3x. I'll just bring this down because I'm running out of space. 3x squared y, and then we can further expand to 2xy y prime plus y squared equal to 5x 15x 3y squared plus 3. Wait. Pardon me, but I think I made a mistake here. Because we have to differentiate, we maintain first, we differentiate to y to cube, 3y squared y prime plus maintain x, differentiate x, 3x squared y cube. Alright, I think we got it this time. 2xy y prime plus y squared equals to 5 15x cube y squared y prime plus 3x squared y. Wait, no, it's not 3. 15 x squared y3. Then we just try to isolate the y prime out. So 2xy y prime minus 15x3y squared prime equal to 15x squared y3 minus y squared minus 15x squared. Isolate the y prime. 2xy minus 15 3y squared equal 15x squared y3 minus y squared minus 15x squared. And then I have to add another page. Get y prime equal to 15x squared y3 minus y squared minus 15x squared over 2xy minus 15x 3y cubed. Okay. And that is your final answer. And obviously you can just simplify further if you want to, but this will get you the correct answer. And as you can see, it can be, for implicit differentiation, sometimes the answer can be a bit more complex, so you may require a bit more practice.